Okay. Good morning to all. In the last lecture, we seen that one theorem. If K is the field and sigma 1, sigma 2 up to sigma n are distinct atomorphism of K, then it is impossible to find the elements. Okay, all the scalars belongs to K, not all 0. Okay, such that A1, sigma 1, A2, sigma 2, A n, sigma n is equal to 0 for all u belongs to K, which means all the sigma n, the distinct sigma 1, sigma 2, all the sigma n's are linearly independent. Okay, and we see one statement. Okay, suppose K is the finite extension of the field F, then prove that GKF, okay, group of all the group of atomorphisms. So group of atomorphisms of K, which leaves every element of F is fixed. Okay, that is relative to F. It's finite group, and its hmm, order of GKF satisfies the relation. Which relation? Relation नहीं दिला कहीं. Wait a minute. Wait a minute. Look at it. Suppose K is the finite extension of F, then prove that the order of GKF, order of GKF is less than or equal to degree of K over F. Okay. Now look at it. This is set of all atomorphism. Okay. The set of
सर
all
तुमचा आवाज खूप कमी
atomorphisms
आला सर.
of K. Okay. And this is the field K. And this is the subfield F of K. And this one is what? GKF. Na? GKF. Okay. Now look at it. Suppose we have to do that order of GKF is less than or equal to degree of K over F. Now suppose proof. Suppose the degree of K over F is equal to n. Degree of K over F is equal to n. And let U1, U2 up to so on UN be the basis element. Be the basis elements of the vector space V over K over F. Okay, K over F. Suppose K over F, degree of K over F is equal to n, and let U1, U2 up to so on UN with the basis element of the vector space K over F. Okay, wait a minute. Suppose we can find n plus 1 distinct atomorphism. Okay, we don't know how many elements in the GKF. Okay, suppose we can find, our assumption is, suppose we can find n plus 1 distinct atomorphisms. Sigma 1, sigma 2 up to so on sigma n, and this is sigma n plus 1 in GKF. In GKF, consider the following system of linear equation. Consider the following system of linear equations. Linear equations in n plus 1 unknown. N plus 1 unknown. Which one? x1, x2 up to so on xn and xn plus 1. And with coefficient in K, capital K. Okay, this one, sigma 1 u1 into x1 plus sigma 2 u1 into x2 plus sigma 3 u1 x3 plus up to so on sigma n plus 1 u1 into xn plus 1 which is equal to 0. Okay, so wait a minute. Wait a minute, okay. Okay, sigma 1 u1 into x1 sigma 2 u2 u1 into x2 plus sigma 3 u1 into x3 up to so on sigma n plus 1 u1 into xn plus 1 is equal to 0. This is the first linear equation. Now second one, sigma 1, apply this sigma 1 on the basis element. Okay, u2 into x1 plus sigma 2 u2 into x2 plus sigma 3 u2 into x3 plus up to so on sigma n plus 1 u2 into xn plus 1 which is equal to 0 up to so on sigma 1 un x1 plus sigma 2 un into x2 plus sigma 3 un into x3 plus up to so on sigma n plus 1 un into xn plus 1 which is equal to 0. Okay, now look at here. How many equations are there? How many equations are there? N equation. How many unknowns?
N equation.
So the system has
n plus
the
1.
unique solution or not trivial solution or non-trivial solution. Non-trivial solution. Look at here. If suppose x1 plus x2 is equal to 1. How many solutions for this equation? One equation into one. Okay. 0, 1, 1, 0, 2, minus 1. Okay. So infinite solution. That means this equation, this system of linear equation has non-trivial solution. Okay. Any doubt up to here? Okay. Look at here. Since the above system
No,
of
sir.
linear equation, the above system of linear equation. Okay, linear equation, linear homogeneous equation. Sorry. Okay, the right hand side is equal to 0 since this linear homogeneous equations. The number of unknowns. The number of unknowns is less than. Sorry, the number of equation is less than number of unknowns. No? Or the number of unknowns is greater than. Greater than number of equations. Okay. The number of unknowns is greater than number of equations. Therefore, this system possesses a number of unknowns. The number of unknowns is greater than number of equations. Therefore, this system possesses a non-trivial solutions. Okay, let non-trivial solution of the above system of equation be. Let the non-trivial solution of above system of equations be. Now find x1 is equal to a1, x2 is equal to a2, up to so on. These are the solution of that unknowns is equal to solution of that equations. Sorry, an plus 1 in capital K. Therefore, we have now put instead of x1 is equal to here a1. Okay, so a1 into sigma 1 into ui, where I running from 1 to n. Okay, plus a2 into sigma 2 into sigma 2 of ui plus a3 into sigma 3 of ui plus up to so on an plus 1 into sigma n plus 1 of ui is equal to 0. Give it an equation number 1 for I running from 1 to up to n. Okay, any doubt up to here? Now let's t be the any arbitrary element.
No, sir.
UI is correct. U1, U2, U3. These are the basis element of vector space K over F. Okay. Now let's take t be the any arbitrary element in K. Let t be an arbitrary element of capital K. And since this U1, U2 up to so on UN, okay, is a basis capital K, so we can find, therefore find, okay, the scalars alpha 1, alpha 2 up to so on alpha n belongs to capital F such that any element of that vector space we can write in the form of linear combination of u1, u2 up to so on un. Okay, so here t can be written as alpha 1 u1 plus alpha 2 u2 plus alpha 3 u3 plus up to so on alpha n un. Okay, any doubt up to here? Okay, now apply sigma 1 on both sides.
No, sir.
Okay, where all the coefficients alpha 1, alpha 2 up to alpha n r belongs to the element of F. Now apply sigma 1 on both sides. Sigma 1 of t is equal to sigma 1 of alpha 1 u1 plus alpha 2 u2 plus up to so on alpha n un. Since sigma 1 is an automorphism, it uses the operation multiplication. Okay, sigma 1 of alpha 1 into sigma 1 of u1 plus sigma 1 of alpha 2 into sigma 1 of u2 plus up to so on sigma 1 of alpha n into sigma 1 of un. Okay, now what is the reason? Sigma 1 is an automorphism. Wait a minute. Wait. And wait a minute. As the sigma 1 is an automorphism. Okay, so sigma 1 of alpha 1 is alpha 1. Why? Because as the sigma 1 belongs to GKF and sigma 1 leaves every element of capital F is fixed. Okay, So sigma 1 of alpha 1 is equal to alpha 1. Sigma 1 of alpha 2 is equal to alpha 2. Okay. As the sigma 1 is an atomorphism. Okay, and sigma 1, sigma 2, sigma 3 up to sigma n are the elements of what? G, K, F. That means that sigma 1, okay, belongs to this G. Labels every element of F is fixed by the definition of GK. So this is the sigma 1 of T is equal to, okay, sigma 1 of alpha 1 is alpha 1. Okay, why? Because alpha 1, alpha 2, alpha 3 are the members of F. Look at here. Okay, so sigma 1 of alpha 1 is equal to alpha 1 into sigma 1 of u1 plus this is alpha 2 into sigma 1 of u2 plus up to so on alpha n into sigma 1 of un. Okay, what is the reason? As this sigma 1 belongs to GKF. That implies sigma 1 leaves every element of capital F is fixed. Okay, and these are the elements alpha 1, alpha 2, to so on alpha n. These are the elements from the field F. So this implies what? Sigma 1 of alpha I is equal to alpha I for all I running from 1 to up to so on. Yeah. Okay. So thus we get what is sigma 1 of t? Sigma 1 of t is equal to alpha 1 into sigma 1 u1 plus alpha 2 sigma 1 u2 plus up to so on alpha n sigma 1 un. Okay, this is for sigma 1. Now similarly for sigma 2 we can write wait. This is for sigma 2 of t is equal to how we can write alpha 1 sigma 2 of u1. Okay, plus sigma alpha 2 into sigma 2 of u2 plus up to so on alpha n of sigma 2 of un. Okay, and up to so on sigma n plus 1. Okay, n plus 1 are there of t is equal to this is alpha 1 into sigma n plus 1 of un. Sorry, u1. Okay, plus alpha 2 into sigma n plus 1 into of u2 plus up to so on this one alpha n into sigma n plus 1 of un. Okay, any doubt up to here? Okay, now multiplying
No,
both
sir.
sides. Okay, this equation by a1 a2 up to so on an plus 1 respectively. Multiplying both sides of this equation of these equations by a1 a2 up to so on an plus 1 respectively and adding we get what we get या equation ला a1 ने multiply कर. Okay, this equation by a2, this equation by an plus 1. Okay, so in the left hand side of the equation we get a1 sigma 1 of t plus a2 sigma 2 of t plus a3 sigma 3 of t plus up to so on an plus 1 sigma n plus 1 of t. Okay, this is the left hand side, which is equal to, at right hand side we get this equation by a1. Okay, this equation by a2, this equation by a3, sorry, an plus 1. Okay, so we get, taking alpha 1 common from here in the first equation, in the bracket, a1 sigma 1 of u1 plus, okay, पूर्ण सगळ्यांना alpha 1 common काढलं, a1 sigma 1 u1, a2 sigma 2 u1, okay, a2 sigma 2 u2, sorry, u1 है ना, हाँ u1, this one is u1, okay, this one is u1 plus up to so on. This is an plus 1 sigma n plus 1 u1. Okay, look at here. This is alpha 1 common, so this is an plus 1 sigma n plus 1 and u1. Similarly, I'm taking alpha 2 common plus alpha 2 in the bracket, a1 sigma 1 u2 plus a2 sigma 2 u2 plus up to so on. This is an plus 1 sigma n plus 1 u2. Okay, plus up to so on. This is alpha n common from here. Okay, alpha n common. What we get? A1 sigma 1 un in the bracket, a1 sigma 1 of un plus a2 sigma 2 of un plus up to so on, an plus 1 sigma n plus 1 into un of un. Okay, is it correct? Any doubt up to here? Okay, now look at here.
No, sir.
From equation 1, what we have? This is, look at it. A1 sigma 1 u1, a2 sigma 2. Okay, put u is equal to u1, I is equal to 1. Okay, so this equation we get is equal to 0 from equation 1. A1 sigma 1 of u1, a2 sigma 2 of u1. Okay, so from equation 1 we get this whole bracket is equal to 0. Okay, so this is equal to alpha 1 into 0. For similarly, for I is equal to 2 from equation 1, this is alpha 2 plus alpha 2 into 0. Okay, plus up to so on. This is alpha n into 0 from 1. Okay, so this is equal to 0. Wait a minute. Okay, any doubt up to here? Okay, so what is the left hand side?
No, sir.
A1 sigma 1 of t. Okay, this is the left hand side. A2 sigma 2 of t plus a2 sigma 2 of t plus up to so on, an plus 1 sigma n plus 1 of t, which is equal to 0 for all t belongs to what? K, because t is any arbitrary element. This is an equation number 2. Thus, we see that if sigma 1, sigma 2, up to so on, sigma n plus 1 are distinct, okay, are distinct automorphisms of K, then what is the value of A1, A2 up to so on n plus 1? These are the non-trivial solution. Okay, trivial असेल तर आपण 0 घेतला असता. Okay, look at here, x1 is equal to a1, x2 is equal to a2. These are the what? Non-trivial solution. That means other than 0. Okay, so thus we can see that sigma 1, sigma 2 up to sigma n plus 1 are the distinct automorphisms of K. Then it is possible to find, it is possible to find A1, A2 up to so on an plus 1. Okay, in the field K, not all 0. Why? Because these are the non-trivial solution such that equation 2 holds. Okay, so this is not possible. Why? By previous theorem. Okay, it is impossible to find that a1, a2 up to so on an such that, okay, their linear combination with sigma 1, sigma 2 up to sigma n plus n is equal to 0. They are linearly independent. Look, not all 0. This is not possible. Hence, our assumption is wrong. What is our assumption? Suppose we can find n plus 1 distinct automorphisms of sigma 1, sigma 2 up to sigma n and sigma n plus 1 in GKF. Okay, this assumption is wrong. Okay, ह्याच्यामुळे तिथे आपल्याला काय मिळते? कॉन्ट्रडिक्शन मिळते. Okay, hence there cannot exist n plus 1 distinct automorphisms. There cannot exist n plus 1 distinct automorphisms in GKF. Okay, similarly, we can prove that there cannot exist n plus 2, n plus 3 up to so on infinitely. Okay, distinct automorphisms in GKF. Okay, hence we have order of GKF is less than or equal to degree of K over F. Okay, any doubt up to here? Okay, n का घेतले?
No,
n
sir.
घेतल्यानंतर काय होईल? जर सिग्मा n घेतले आपण तर इथे किती इक्वेशन येईल? Okay, look at here. So n unknowns in n equation. Homogeneous linear equation आहेत बरं का? n unknowns आहेत, n इक्वेशन आहेत. किती सोल्युशन असतील? युनिक सोल्युशन.
Unique solution.
युनिक सोल्युशन ते 0 ही असू शकेल, ट्रिवियल ही असू शकेल. Okay, that's why here we taken sigma n plus 1. Look at here. X plus x1 plus x2 is equal to 7 and x1 minus x2 is equal to 1. How many solutions for these two equations? Two unknowns.
Unique solution.
युनिक सोल्युशन असेल तर ट्रिवियल असू शकेल, काय सांगता येत नाही जर इथे हे राईट हँड साइड 0 असेल तर. ओके, सो इफ सिग्मा एन जर आपण घेतले, सिग्मा एन जर घेतले तर ह्याला युनिक सोल्युशन येऊ शकतात, म्हणजे ट्रिवियल सोल्युशन येऊ शकतं. ओके, मग जर ट्रिवियल सोल्युशन आला तर आपण इथे हे काय म्हणतात, वेट अ मिनिट. Look at it. If this is above system of the linear homogeneous equation, number of unknowns is greater than number of equation. Therefore, this system for this is not real solution. If suppose the number of unknowns is equal to number of equation, then that system may have unique solution or trivial solution. So we cannot find this x1 is equal to a1, x2 is equal to a2, xn plus 1 is equal to n plus 1. Okay, that's why here we taken as a sigma n plus 1. Okay, आपल्याला नॉन झिरो असायला हवे, नॉट ऑल झिरो. Okay, that's why here we taken sigma n plus 1. Similarly, for sigma n plus 2, here the number of unknowns are xn. Okay, xn plus 1. And number of equations are n. So this system is also a trivial solution, non-trivial solution. The number of equations जास्त असतील, sorry, number of unknowns जास्त असतील आणि number of equations कमी असतील तर त्याला सिस्टम ऑफ लिनियर इक्वेशनला नॉन ट्रिवियल सोल्युशन, इन्फायनाइट सोल्युशन मिळू शकतात. बरं का? बीएससी झाला असेल की मॅट्रिक्स मध्ये. ओके, एनी डाउट अप टू हियर?
Yes, sir.
Okay. Now the next point is
No, sir.
elementary symmetric function of the element of the field. Okay, look at here. The next point is एक छोटा सा concept है elementary symmetric function. Elementary symmetric function of the elements of the field A. Of the elements of a field. Okay, look at the definition. Let alpha 1, alpha 2, up to so on alpha n be n elements of a field F, capital field F, then y is equal to, or y1 is equal to alpha 1 plus alpha 2 plus up to so on alpha n, which is equal to summation I running from 1 to n alpha I. Okay, alpha I. This is the elementary symmetric function of a field F, the y1, and y2 defined as y2 is equal to summation I is less than g. Okay, alpha I into alpha g. Okay, this is the again elementary symmetric function of the elements of a field F, y3 defined as summation I less than j less than k into alpha I into alpha j into alpha k. Okay, similarly up to yn we get alpha 1 into alpha 2 up to so on alpha n. Okay, so these are the elementary symmetric function y1, y2, y3, yn. Okay, of the elements of alpha 1, alpha 2, alpha 3, alpha n up to so on alpha n. Okay, that is the element of the field F. Okay, so what is the elementary symmetric function? These are the y1 is equal to summation of alpha I running from 1 to j. y2 is equal to I less than j alpha into alpha j. y3 is equal to I less than j less than k summation alpha into alpha j into alpha k. Okay, are called elementary symmetric function, elementary symmetric function of alpha 1, alpha 2 up to so on alpha n. कौन है elementary symmetric function? Is y1, y2, y3 up to so on y. Okay, एक example घेतल्यानंतर ते व्यवस्थित लक्षात येईल. Look at it. Suppose alpha 1, alpha 2, alpha 3 up to so on alpha n are the n elements of the field F. Then the product of x minus alpha 1 into x minus alpha 2 up to so on. Okay, product into x minus is equal to n, right? Okay. What is the degree of this polynomial? Suppose this is polynomial x minus alpha 1 x minus alpha 2 x minus alpha n. Okay, degree का n है. So
N.
minus. This is the first time plus, second one is minus. So y1 into x raised to n minus 1. Now plus y2 into x raised to n minus 2. Then again minus now. y3 into x raised to n minus 3. Okay, up to so on. Plus. Wait a minute. Minus 1 raised to n. Okay, yn. What is yn? Alpha 1 into alpha 2 into alpha 3 up to so on alpha n. Okay, this is for the n elements of that way. Okay, for our sake of understanding, take the three elements. Consider the three elements first. Consider हे समजायला अवघड जाईल तुम्हाला. तीन एलिमेंट्सला घेतल्यानंतर लगेच consider for three elements. Okay, suppose this is x minus alpha 1 into x minus alpha 2 into x minus alpha 3. Okay, has a polynomial which is equal to x square minus alpha 2x minus alpha 1x plus alpha 1 alpha 2 into x minus alpha 3. Okay, now after multiplication we get, wait. After the multiplication of this bracket we get x cube minus alpha 1 plus, okay, directly alpha 2 into x square plus alpha 1 into alpha 2 into x minus alpha 3 x square plus alpha 2 alpha 3 x plus alpha 1 alpha 3 into x minus alpha 1 alpha 2 into alpha 3. Okay, after the rearranging we get this is x cube minus coefficient of x square. Okay, wait a minute. कुठं चुकते काय? Alpha 3 into x square येते का? कुठे? Correct. Minus n पण कॉमन केलं ना. Alpha 1 plus alpha 2 plus alpha 3 into x square plus now. Take the coefficient of x. Alpha 1 alpha 2 plus alpha 2 this one. Alpha 3 plus alpha 1 alpha 3 into x minus alpha 1 alpha 1 alpha 2 into alpha 3. Okay, now look at this one, which is equal to, this is x cube. What is this? y1 na elementary symmetric function of alpha 1 alpha 2 and alpha 3. This is y1 into x square plus, now this is, look at here, what is y2? Y2 is summation of I less than j. Okay, kail mo sa 1 2 2 3 and 1 3, that is alpha 1 alpha 2 alpha 2 alpha 3 alpha 1 alpha 3. Okay, this one plus y2 into x, and this is alpha 1 alpha 2 alpha 3 means y. Okay, where write down y1 is equal to alpha 1 plus alpha 2 plus alpha 3. y2 is equal to alpha 1 alpha 2 plus alpha 2 alpha 3 plus alpha 1 alpha 3, and y3 is alpha 2 into alpha 3. Okay, any doubt?
No, sir.
Okay, so the y1, y2, y3 up to so on yn, these are elementary symmetric function of alpha 1, alpha 2, alpha n, which are elements of capital F. Okay, now we move towards the next definition is what is the normal extension. Okay, normal extension. Finite extension झाला आहे, अल्जेब्रिक एक्सटेन्शन झाला आहे, अजून कोणती एक्सटेन्शन झाली? फायनाइट एक्सटेन्शन, अल्जेब्रिक एक्सटेन्शन, अजून कोणकोणते झाले एक्सटेन्शन? नाही लक्षात. चला, डेफिनेशन. नॉर्मल एक्सटेंशन पहा जरा. फाइनाइट एक्सटेंशन के finite extension of a field capital F is called the normal extension. The normal extension of F. Okay, a finite extension of a field F is called normal extension of F if fixed field of GKF is capital F. Okay, so this is the definition of GKF, sorry, normal extension. Okay, what is normal extension? A finite extension of a field F is called the normal extension of F if the fixed field of GKF is F. Okay. This is the field F. This is the field K, and this K, the finite extension K. Okay, finite extension K of the field F. Okay, so this is the finite K is the finite extension of F, and this one is set of all atomorphism of K. Okay. Now collection of those atomorphisms of K which leaves every element of Fx, F is fixed. Okay, so this is GKF. Okay, this is the what? Set of all the atomorphisms on the field K. And what is GKF? The group of atomorphisms of K which leaves every element of capital F is fixed. And if the fixed field of this GKF is equal to F itself, has field the same, the normal extension. Okay, the K is called normal extension of F. Okay, look at here for the example. Q root 2 is normal extension of Q. Why? Look at this one. What is A of Q root 2?
A plus B root to A minus B root.
Okay. This is set sigma 1 and sigma 2. What is sigma 1? Sigma 1 का होता है A plus B root 2. Is identity mapping. And what is sigma 2? A plus B root 2. Sigma 2 of A plus B root 2 is maps to A minus B root 2. Okay. Now, okay. Hmm. Now, what is G of Q root 2 and Q relative to Q? Hmm. What is the set of those automorphisms which leaves element of Q is fixed. So in that set, both the automorphisms which leaves element of Q is fixed. Okay, हा sigma 1 apply करा किंवा sigma 2 apply करा कोणावर Q root 2 सॉरी Q वर Q root 2 हा Q root 2 apply केला तर काय होतोय किंवा Q वर apply केला तर तो काय करतोय ह्याच्यामध्ये root 2 चा पार्टच नाहीये तुमच्याकडे ओके या Q मध्ये so this sigma 1 and sigma 2 leaves every element of Q is what fixed. So what is the set? This is the set G Q root 2 Q is nothing but sigma 1 and sigma 2. Okay. Now what is the fixed field of G? Fixed field of G. Fixed field of this set must contain this Q. Okay, but we don't know this that equal to Q or not. Okay, fixed field of G is a fixed field of GKF. F is contained in fixed field of GKF. Okay, fixed field of GKF. Okay, what is fixed field of this one? What is the meaning of fixed field of this one? G Q root 2 is काय fixed field आहे हे सिग्मा 1 आणि सिग्मा 2 कोणते एलिमेंट फिक्स ठेवतोय कोणते एलिमेंट कोणत्या फील्ड मध्ये फिक्स्ड field of G Q root 2 गोल होते लक्षात ठेवा बरं कसं डेफिनेशन is equal to set of those automorphisms set of those elements from Q root 2 such that sigma I of x is equal to x for all x sigma belongs to GKF है ना हाथ से ना से sigma I of x is equal to x for all sigma belongs to G Q root 2 Q. Okay. मग हा काय कलेक्शन आहे व्हॉट आर द कलेक्शन असे कोणते एलिमेंट येतील या फील्ड मधून हा तुमचा Q रूट आहे Q root. So take these elements Q याच्यातले कोणते एलिमेंट घ्या all sigma 1 and sigma 2 fix the every element of Q is fixed. So fixed field of G Q root 2 and Q is equal to what? Q. Okay. So hence, by the definition of normal extension, Q root 2 is normal extension of Q. Okay. Any doubt? Any doubt up to here? अजून एक एक्झाम्पल घेऊयात जो नॉर्मल एक्सटेंशन नाहीये.
No, sir.
Second example. This is Q field and the Q of 2 raised to 1 by 3. This is the finite extension of Q. Okay. Now look at here. We have to find all the automorphisms on Q of 2 raised to 1 by 3. किती automorphism येतील याच्यात? काल पाहिलंय पण. How are exist on this field? काय करावं लागेल फक्त आपल्याला ह्याची इमेज काढावं लागेल ना Q वर तर एकच एलिमेंट एकच ऑटोमॉर्फिझम एक्झिस्ट होते कसं काढलंय तू you have to find automorphisms on Q of 2 raised to 1 by 3. Okay, suppose phi is the automorphism. We have to find the only image of 2 raised to 1 by 3. Okay. Now, what is phi of 2 is equal to phi of 2 raised to 1 by 3, 2 raised to 1 by 3 into 2 raised to 1 by 3. So we can write in the form of this, which is equal to 2. But phi is an automorphism, so this is phi of 2 raised to 1 by 3 into phi of 2 raised to 1 by 3 into phi of 2 raised to 1 by 3, which is equal to 2. That is phi of 2 raised to 1 by 3 bracket q is equal to 2. Okay, now taking the cube root of both sides, so we get phi of 2 raised to 1 by 3, which is equal to 2 raised to 1 by 3. Okay, अजून एक दोन रूट देईल w into 2 raised to 1 by 3, w square into 2 raised to 1 by 3, but these are the complex numbers, not belongs to q of 2 raised to 1 by 3. Okay, that's why we have not taken these are the two mappings. Okay, automorphism म्हणजे पाहिजे म्हणजे काय पाहिजे तुमचं, domain आणि codomain same भाव आहे. Okay, so the image of 2 raised to 1 by 3 is 2 raised to 1 by 3. That is what phi must be an identity mapping. Okay, so only identity mapping exists on q of 2 raised to 1 by 3. So a of q of 2 raised to 1 by 3, only identity mapping there. Okay, and that is sigma 1. Suppose that identity mapping is sigma 1. If you take g of q of 2 raised to 1, हा gkf काय असतो तुमचा, हा एक तसा ग्रुप असतो. Okay, so take g q of 2 raised to 1 by 3 relative to q, which is equal to only sigma 1. Okay, gkf is a size, is a group of not ak. Now find out the fixed field of g of q of 2 raised to 1 by 3 q. What is the meaning of this one? Fixed field of g is that sigma 1, by definition, take the elements from q of 2 raised to 1 by 3. Okay, such that sigma 1 of x is equal to x for all. Okay, sigma no, sigma here. For all sigma belongs to g. Okay, this set. That is this one. आता ह्याच्या सेट मध्ये एकच सेट आहे तुमचा सिग्मा 1. ओके, हा सिग्मा 1 कोणते एलिमेंट फिक्स करतोय? ह्याच्यात तिथे फिक्स करतोय सिग्मा 1 तुमचा आयडेंटिटी मॅपिंग आहे. Okay, sigma 1 is identity mapping. So sigma 1 leaves every element of q is fixed, but also sigma 1 leaves every element of this field is also fixed. Okay, so that the fixed field of g q raised q of 2 raised to 1 by 3 on q is nothing but what? Which is not equal to q. Hence, q of 2 raised to 1 by 3. 2 raised to 1 by 3 is not normal extension of q. Okay, any doubt? Wait a minute.
No, sir.
Okay. C of C is the normal extension of R. C, which is equal to third example. R of I is normal extension of R. Why? This is R. This is C. Okay, that is R of I. How many automorphisms on C? Sigma 1 and sigma 2. Okay, दोन automorphisms आहेत sigma 1. काय sigma 1 तुमचा? Sigma 1 of A plus IB is equal to A plus IB. sigma 2 of
A
A
plus I B.
minus IB is equal to, sorry, A plus IB is equal to A minus IB. Okay, if you take that is
A minus I.
GKF, which is equal to G of CR, which is equal to sigma 1 and sigma 2. Okay. Then fixed field of GCR. Hmm. How many? Wait a minute. What is the G? Fixed field of G means take the collection from C such that sigma of x is equal to x for all sigma belongs to GCR. Okay. आता हे सिग्मा आणि सिग्मा 2 कोणते एलिमेंट फिक्स करतायत? सी मधल्या कोणत्या एलिमेंटला फिक्स करतायत? आर मधल्या प्रत्येक एलिमेंटला फिक्स करतायत. वाय? बिकॉज ते हा आय बी तुमचा पार्टच नाही. ओके, आर मध्ये. अँड याच्यातले काय बाहेरचे फिक्स करतायत का? नाहीये. सिग्मा 2a plus ib is equal to a minus ib. So this is the r. x मध्ये असे c मध्ये असे एलिमेंट घ्या, तो sigma of x is equal to x for all sigma belongs to GCR. So that set is nothing but r. Now here the fixed field of G is equal to what? R. Hence C is the normal extension of R. Okay. असं पाहिल्यानंतर लगेच नाही समजणार होते आपल्याला एक्सटेन्शन आहे की नाही, ते चेक करावं लागेल. ओके, एनी डाऊट? ओके.
No, sir.
एक थेरम आहे, त्याचं स्टेटमेंट बघूया आणि त्याचं प्रूफ नंतर बघूया. ओके, टुमॉरो. व्हॉट इज दॅट थेरम? लुक ॲट इट. Suppose K is finite extension. A is finite extension of a field capital F of characteristic 0. Okay, and capital H is a subgroup of GKF. Okay, and let KH be the fixed field of capital H. Then prove that. थेरम मोठा आहे, पुढच्या लेक्चरला हा एकच थेरम होईल बरं का. Prove that first one, degree of K over KH is equal to order of H. Okay. Second one, H is equal to G K H. Okay, काय सांगतोय पहा. F. Okay, K is the extension of F. Okay, this is the set of all the atomorphism of K. Okay, what is GKF? GKF is the subgroup of atomorphism. Okay, subgroup of atomorphisms of K which leaves every element of F is fixed. What is KH? Yes, the diagram KH is the fixed field of H. But what is H? What H is the subgroup of GKF. That's a subgroup of H. This is H. Okay. And KH is the fixed field of H. Okay. म्हणजे हा KH तुमचा इथे येईल. ओके, आता एक मिनिट लक्ष द्या. ह्याच्यामध्ये तुमच्याकडे सगळे ॲटोमॉर्फिझमचे सिग्मा आहेत. ओके, सिग्मा 1, सिग्मा 2 अप टू सिग्मा. जसे जसे इथे सिग्मा कमी होत जाते, तुमचा हा फिक्स्ड फील्ड ऑफ एच काय होईल? मोठा 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 होत जाईल, एक्सटेंड होत जाईल. ओके, फिक्स्ड फील्ड साठी काय? फॉर ऑल सिग्मा बिलॉंग्स टू दॅट हे ना ॲटोमॉर्फिझम जीकेएफ. जर या जीकेएफ मध्ये जर एलिमेंट जास्त असतील, जास्त सिग्मा असेल, तर ते कंडिशन काय झाले, स्ट्रिक्ट स्ट्रिक्ट कंडिशन झाले, अजून कंडिशन वाढले त्याच्या, म्हणजे हा फील्ड काय होतो, या फिक्स्ड फील्ड ऑफ जी केफ हा काय होईल, लहान लहान होत जाईल. जसे या जी मध्ये किंवा ह्याच्या सबग्रुप मध्ये, ए के च्या सबग्रुप मध्ये कमी एलिमेंट्स असतील, समजा इथं हा एच, इथं सिग्मा वन हा एकटाच आणि हा सिग्मा टू हा एकटाच, इथे सिग्मा वन आणि सिग्मा टू दोन फील्ड, दोन हे आहेत ऑटोमॉर्फिझम. ओके, नाव द फिक्स्ड फील्ड ऑफ जी इज काय येईल, इज, जर हा एफ असेल देन फिक्स्ड फील्ड ऑफ एच काय येईल, म्हणजे ह्याच्यापेक्षा मोठा असेल तो, कळते? एनी डाऊट? ओके,
Yes, sir.
त्याच्यामध्ये एकच सिग्मा आहे तुमच्याकडे, जर
Yes,
ह्याचा
sir.
फिक्स्ड फील्ड काढायचं असेल तर मला हा सिग्मा वन आणि सिग्मा टू ला पण मला हा कंडिशन सॅटिस्फाय करायला पाहिजे. सिग्मा वन ऑफ एक्स इक्वल टू एक्स, सिग्मा टू ऑफ एक्स इक्वल टू एक्स. पण जेव्हा आपण सिग्मा याचा सिग्मा हे काढेल फिक्स्ड फील्ड, त्यासाठी मला हा एकच मला कंडिशन वापरावं लागेल, सिग्मा वन ऑफ एक्स इक्वल टू एक्स. ओके, तुम्ही या एफला तर कंटेन करेलच, त्याच्यापेक्षा हा मोठाही असू शकेल. ओके, जसे जसे सिग्मा लहान लहान होत जात आहेत, कमी होत जाते, तसं मला फिक्स्ड फील्ड वाढत जातं. ओके, आणि जर तुमचा सिग्मा हा फक्त आयडेंटिटी मॅपिंग असेल तर हा पुढे काय फिक्स्ड फील्ड, जर तुमच्या जी मध्ये फक्त बघा सिग्मा वन हा एकच आयडेंटिटी मॅपिंग असेल तर त्याचा फिक्स्ड फील्ड काय, होल फील्ड के. ओके, एनी डाऊट? दिस पार्ट वी विल सी इन द नेक्स्ट लेक्चर. ओके.